Okay, so we've got an example that's going to be to do with resolving forces. We've got a body of mass 4 kilograms pulled along a rough horizontal table by a horizontal force of 24 newtons against a constant friction force of magnitude 6 newtons. Given the body is initially at rest, find the acceleration of the body, the distance travelled by the body in the first 4 seconds, and then finally the magnitude of the normal reaction between the body and the table. So this sort of question, first thing you want to do is draw a nice force diagram, show what's going on. So we've got his body, or we draw it as a box just because that's convenient. Put his mass inside, and then we can start labelling all the forces on. So we're pulling with a force of 24 newtons. Friction is opposing that, and that is 6 newtons. The other forces acting are the weight, and the weight of the box or body is mass times g, so 4g. And the only other force acting is the normal reaction force, which is there. And the other thing we want to label here is the fact it's accelerating, so we're pulling it to make it accelerate this way, an acceleration of a meters per second squared. Okay, so in part A, we are trying to find the acceleration A. So if we resolve horizontally, so this way is going to be positive because we are accelerating that way. So resultant force would be 24, subtract 6. That's equal to the mass times the acceleration, so Newton's second law, F equals ma. So 18 is equal to 4a, so therefore a is 4.5 meters per second squared. Question B is really nothing to do with forces. It's really to do with the kinematic equations. So we want the distance travelled in the first 4 seconds. So we're saying time is 4 seconds. The acceleration is what we just worked out a moment ago. We're trying to find the distance, so we can find the displacement s. The other thing we know is that the initial velocity is 0 because it's starting at rest. So these 4 things, the equation that connects them is s equals ut add a half at squared, and we just substitute it all in. So we're going to get 0 plus a half times 4.5 times by 4 squared. That will come to 36 meters. Okay, then part C, magnitude of normal reaction between the body and the table. That's just a case of resolving vertically. So there's no vertical acceleration, so the two forces here, a bit closer, so R and 4g, they're cancelling each other out. Their resultant force will be 0. So therefore R subtract 4g equals 0. So in other words, R is equal to 4g, or 39.2 newtons, taking g to be 9.8.